الجلسة النقاشية تحت عنوان الآثار الاجتماعية والاقتصادية للشراكة بين القطاعين العام والخاص في مجال تحلية المياه، ويديرها المهندس عمرو سعودي.
Ladies and gentlemen, we will now begin the panel session entitled Desalination Public-Private Partnership Socio-Economic Effects. It will be moderated by Engineer Amr Saudi.
Thank you for the introduction. Now we start the first panel discussion. Dr. Atar Hanoura, kindly. Mr. Rajesh. Mr. Nash. The panel discussion under the title Desalination Socio-Economic Challenges Egypt. We have three panelists. Dr. Atar Hanoura. Dr. Atar have more than 42 years of professional experience in different capacities and business sector. He is holder of law degree from Cairo University in 2015, diploma in large procurement IORI from Italy 2004, and bachelor's degree from engineering from Alexander University in 1981. Dr. Atar Hanoura classified as BBB expert with solid procurement and contract management experience. Professional business experience is mainly gained due to working at multinational organizations since 1997. 9 years at the World Bank as a management information system and procurement expert experience, then extended to cover the full project management, financing, and contract management in the Middle East and North Africa region. Dr. Atar managed feasibility studies, preparation, and tender of several BBB projects in utilities, transportation, health, education, ports, and communication sector, in addition to creating additional BBB pipeline projects. He worked in the private sector as a deputy general manager, business development director, and vice president of different regional and local organizations, with a strong customer needs and a continuous stakeholders engagement. Such variance providing high exposures in wide business aspects in the Egyptian and Middle Eastern market. He joined the Ministry of Finance of Egypt to participate establishing the BBB Central Unit at 1st of February 2007. He was appointed as the director of the BBB Central Unit, and he also was responsible for implementing BBB initiative on a national basis and drafting the BBB legal framework in Egypt since May 1910. Second panelist, Mr. Rajesh. That's fine. Mr. Rajesh. Mr. Rajesh is a senior water and sustainability specialist with the World Bank Cairo office since 2019. He is a team leader for the Sustainable Sanitation Service Program, a program for results investment in Egypt. Rajesh has played a key role in the country climate development report, Egypt, and also leads the water sector for the Egypt Infra SAP. He also worked closely on mobilizing private sector financing in desalination, wastewater, and non reduction in Egypt and Jordan. He was earlier based in New Delhi, where he was responsible for jointly leading the $1 billion support to the government of India on the cleaning for the river of Ganga, where he played a leading role in structuring innovative private sector participation through a hybrid annuity-based model. Rajesh has over than 20 years of experience working across Middle East and North Africa, South Asia, East Asia, and North America, prior to coming to the World Bank. Rajesh worked over 12 years in advising government, private sector, and multilateral agencies on infrastructure sector. He also worked for the Monetary Authority of Singapore in financial market surveillance. Rajesh has a baccalaureate and master degree in business from University of Delhi and a master in public administration in international development from Harvard Kennedy School. The third panelist, Mr. Vignesh, he is a strategic business development manager at Wetico from Saudi Arabia. It's other company, not Wetico, not that consulting office. A leading water and wastewater multinational with HQ in Riyadh, headquartered in Riyadh, Saudi Arabia. Wetico has recently ranked second in the global list of desalination plant contractor by International Desalination Association for blockbuster year, contracting 1,500 million liters per day across Middle East and North Africa. His company excellence is backed by its house design and engineering center of company in Riyadh, Cairo, and Seville. He is dedicated old career. Vignesh has excelled in international business development and strategic partnership for global expansion of business footprint. He has constantly voiced the need of sustainable future in his position as a water and environment consequence citizen and global water professional. So now we start the panel discussion with the presentation. We prepare it. I explain the presentation, and then we start the discussion with question with the panelists. And after that, I will open the discussion with the attendee. Our presentation today about desalination socio-economic challenges in Egypt. In Egypt, all of us know that we have our Egyptian plan of desalination to work, especially to work with BBB model. BBB is public-private partnership. Before in Egypt, we are used to go to the government, cover everything, pay the money, build the planet, operate the planet. Now, the government strategy to transfer to BBB. In this presentation, it includes an introduction and the destination, a brief and destinations Arab countries, and then destination consideration, destination industry challenges, what we focusing in this presentation, and how to improve destination industry environment, and what is the public-private, how we can transfer the risk for the public-private partnership in destination, and then the conclusion. This is a brief, just introduction to show that the capacity around the world, maybe this statistic from 2019, we can find in the Middle East and the world a lot of changes happened in the 2 and 3 years, so we're not able to update the data every day. We know in Saudi Arabia, a lot of destination projects, in Algeria, a lot of destination projects, in Morocco, in Tunisia, even Egypt. Desalination, we have more than 15,000 desalination plant operation around the world. The figures shows the capacities for the desalination and what is the technology used. It's clear that nowadays that the reverse osmosis is the most type of desalination technology used around the world for the time being. This figure shows a percentage of the distribution destination across the areas around the world. It's clear that more than half of the destination planet in the Middle East. This graph shows the countries, the highest 20 countries facing the water shortage or water stress. We can find that we highlighted in Kuwait, Saudi Arabia, Egypt, Algeria, and so on. We can find that all of, about 14 countries from the top 20 from the Arabic country and Middle East and North Africa. This map, we prepared it in 2019. It shows the existing capacity for the desalination around the Arabic country. In this time, we have maybe some comment about Sudan, but we can Pass it, okay. It's about 19 cubic meter per day, and this is a distribution around the world. And show this map, we like to present it to show how it's a distribution of desalination around our world and how the challenge we face. This also the statistics for desalination capacities around the Arabic countries in 2019. And this in the blue, in the yellow or orange color, we can find that the expected. We make these studies in 2023, expected to be in 2023, but most of this data changed and become for considering the Egyptian desalination program. The map to the left show it's prepared in from 1993 up to 2023. The distribution of the desalination plant and if it's existing or completed or ongoing or planned, and the map to the right showing the first stage from the strategic plan. We'll come back to the map, please. So the map to the right, show the distribution of desalination plant for the strategic plan from Egypt for the first plan. Of course, all of us know that maybe some changes happened for this sites, but because every day we update it, it's updated in Egypt, so we can consider it as a reference or as a guide until we settled the last with total capacity about 3 million cubic meter per day. These are information that these capacities and location may be under modification under some studies, may be modified. Now we'll introduce what's the challenge. I like always to not only talking about this, not mention desalination. I like to name it desalination industry. What's the challenge? What's the challenge facing the desalination industry? It's expensive. The desalination expensive. The cost of cubic meter for desalination is expensive. So because of high cost of energy and capex and opex, environmental impact. And also we have the challenge for the operation and maintenance challenges. The process is complex, not easy process. And also we here like to add the social challenges, especially in a country like Egypt. And economic situation and psychology states from the people and the market. And at the end, the laws, the tax, and the tendering method. This is a chart showing the cost of water production. We have considered if we're going to the real cost for the water cubic meter, the capex and opex. Dr. Ati, you can't follow. It's not clear. Okay, so we have considered the capex and opex, capex capital cost and opex operation cost. And this chart showing the items of the total water cost, especially if we're going with BBB model. This graph, okay. These graphs show a breakdown, example of the breakdown. Of course, water treatment and desalination, from my point of view, it's case by case. Maybe this breakdown changes from the percentage, but this makes a common breakdown. The chart to the left showing us the breakdown for the capex, the percentage of each the intake, costing about 7% of the capex of the land. Of course, if this for conventional desalination plant, for common case, special case, in some cases with some change, this percentage changes. And the figures to the left showing the main factor affecting the operating cost. It's clear that electricity or energy consumption or energy cost, it's more than 50%. Again, these figures and percentages not common. It's case by case. So this is for one case. And we're talking about the chemicals, spare parts, labor, and membrane, and so on. And some references may use another breakdown. So we have a lot of references we can refer to. And that's clear the total water cost we have to consider capex and opex, because previously when we working for the EPC project in the governmental or the private sector, it's not easy to consider both. Maybe in the erection or implementation stage, we're focusing that to get the minimum price for the implementation of the project, regardless what is the OPEX, what is the operation cost. But when we go to the triple B model, we have to consider both. And this figures the challenges in destination. We have some challenges for expensive. Why? We have a lot of challenges in destination planet. One of them is the effect of aging or the aging for the membrane. After operation of the membrane for 1 year, 2 years, it become less permeability, it become fouling, so it reduce less water with high energy consumption. So we have to consider both, and we have to make a balance between the OPEX and CAPEX. Also, in some places, it's a variation of water source parameters that changes the temperature, maybe some parameters affecting the intake system, so it affects the chemicals used in the destination plants. And one of the issues we have to consider when we calculate the operation, the total water cost, that we have considered it in annually, not monthly or day by day or something like that. We have to consider the shutdown of the plants for the operation maintenance along the year. This is one of the issues have to be considered when we go to calculate the total water cost. Also, the people, the fouling of the membrane, because the organic and inorganic storage in the water source, and I think consumable. I explain this. That's the second slide. The second challenge, it's known for all us, that desalination have a high negative effect for the environment. This graph shows that we have three main, most of the reference talking about only two items: the air pollution or the green hydrogen, the effect of CO2 emission, because the desalination is one of the highest or the intensive energy consumption process. The second one, all of us know, the bad or the negative marine effect or the marine pollution, because of the project water or brine that contain chemicals and contain some salts with some concentration, different temperature, so it affects the marine life. And in Egypt, we have a challenge that we have a big amount or a certain percentage for the national income from tourism, that if we consider desalination for some area, we have to keep the marine life in a proper way to not affect the tourism and the income for the country. The third one of the importance I like to mention is the solid waste. We have one example. It's clear the membrane itself. What we do with the membrane after it's finished, after how we can deal with it, how we can recycle it, the chemicals, the spare parts. Have we considered, because it's also it's a negative effect for the environment. So we have a big challenge in the environment in desalination. It is clear that the estimated carbon footprint for the RO system is 1.4 to 6.6 kilogram CO2 equivalent per cubic meter. So just to clarify how it's the value of the emission of CO2. This graph we try to make some calculation based on the 3.3 million cubic meter base that's planned to be the first stage or first phase in the strategic plan. If we go to use the oil as a source for electricity for the destination planet, the emission will be 12,000 mega CO2. If we go to solar PV, solar, nuclear, wind, it's nonsense. I think because of that, the government decided to go to supply the destination system planets in the Triple B Egypt program to be with renewable energy. We can see the effect. Also, if you natural gas, it's about half if comparing if we're using the oil. And this graph, I like it. We make some calculation to make it easy for the people, for the audience, to show that if we produce 1 cubic meter per day from RO system, and we need for this production 3 kilowatt per cubic meter, it's equal to drive a car for about 16 kilometers per day for 1 year. If we go to produce a cubic meter per day from destination using RO, we need 4.5 kilowatt per hour cubic meter per hour. We equal the emission if we drive a car for about 24 kilometers per day for 1 year, just to have the feeling. And again, we're talking at the mirror life. Show it at the details. This is the waste, the solid waste, like a solid waste or terrestrial environment. We all of us know the membrane, the cartridge filters, the chemicals, even the spare parts, the solid, the stainless steel, the fiberglass, the PVC. We have a lot of waste in destination, and we put it in a remote area. And I don't know till now what's the negative effect of the environment for the material, for the membrane, in the environment, in the solid. We have, in a lot of international conference and congress, we discuss this, and the destination industry need to make more research and in this research and development in this item, because I think we receive a paper in the competition, in our competition, that one of the applicants used the old membrane to make it like alpha filtration for other application. It's from the first line, but it's not from the winner. Maybe next time. The challenge is operation and maintenance. Desalination system is the people who are working in desalination, especially who work at the site for the operation and maintenance, facing a lot of challenge every day. Because as we'll explain later, the desalination system consists of a lot of items. Each item has its own behavior, its own performance, its own character, and how he can deal with all of this integrated system to keep it run in a proper way. And even he have the skills to do this, he become boring. The people, the human being behavior from time to time become boring from this. Every day I do this, everything. So after that I will go to the document and say, write the same data. And but because of that, we need in the desalination industry from the training and the education for the people working in the desalination system, not to work. It's not only enough to prepare the people to work in desalination. We have to consider that every time we have to make more training, more to make the people fresh, because that will affect their performance in the operation, in the daily operation. And of course, and the second thing, that desalination, especially with RO system, is risky. We're working in high pressure with hazard chemicals and so on. So we have to consider the safety. So we have to make an optimization between the operator to be careful from their safety and to work in the proper way and not become boring. It's a psychological point, but at the end, it's a fact. 10 years ago, 12 years ago, with one company here in staying here in the hall, they asked me to make analysis for they have a lot of operation and operation maintenance. They have a lot of contract for operation maintenance. And they have a problem. The owner feels that the performance of the operator is not like that. So we make a survey along Egypt, and I'm going to visit each site and discuss and talking with the operator, with the technician, with the engineering. They qualified, they technically qualified. But what's the problem they facing? The problem they facing is that the dress, they have a dress, the owner, they have a good dress with good material, but with a blue color. I don't know, I don't remember the name in English. In Afrita, I don't know the overall, okay. In the blue. So their colleagues in the area always say that you are like the presence, present, you are not, so they don't like to work, to wear these clothes. And my advice, my recommendation to him that he have to change the color. And after that, we measure the performance and it's become higher, just to concentrate about the psychology and the mentality of the people. Because without that, we're not able to do our job. All of us, I think all of us. Okay, we can. The process complexity. Desalination system, this equation, the desalination system consists of a lot of equipment. Each equipment has its own governing equation. I will present this deeply in the last presentation today, inshallah. Each equipment has its own equation. These equations in the screen, not all the equation. The screen is not enough to put all the equation. Dr. Ibrahim, my doctor in master degree and in the college, who is learning me this equation. He was asked today. I am proud that he attends the conference. So how to deal with all of this equation? It's not easy. The process is too complex. What happens in the real life that we ignore a lot of things. Because at the end we have some red lines that we have to produce the water. The people have to drink. This is one of the challenges. Because of that, we need a high-skilled person working in desalination, especially in the operation and maintenance. Okay, for design, we can go to the consultants, companies, and find a good optimal design. And as I mentioned in my lecture, that if I buy Rolls Royce and my driver not change the oil, the motor will failure, even it's Rolls Royce. So the operation and maintenance is one of the important issues in desalination. The social challenges. Here I like to prepare this map about the Arab country, and we just mentioned that some countries have rivers. For all of us in the hall now, if we live for decades depending in the rivers, especially in Egypt we have the Nile River, and when we standing and in front of the Nile River and see the water coming like this and this, we have a good feeling. We have a good feeling when we open the tap and drinking the water coming from Allah. This is one of the biggest problems we're facing in Arab countries, basically depending for river water. Especially in Egypt, if you look at the water country, we are more than 70,000 years we are staying in this land depending on water from the Nile River. And now, they say that we have to go to the destination, and the people say that we have to drink salt water. So it's a big challenge. We face this challenge in El Qusir, it's one city in the Red Sea. And I will discuss with my driver this time. He's from El Qusir. I told him, why you don't like to drink water from the desalination plant in El Qusir? He told me, why we drink a salty water and you have a water from the Nile? He not convinced. He can pay in this time 50 pounds for 20 liter coming from Nile River, but not pay one millim to drink. If it's free, he don't like to drink water from desalination. Maybe it's not the culture in Saudi Arabia. Maybe it's not the culture in Emirates, in Bahrain, other countries. Why? Because the people in this age already raised up and born in the country based in desalination. So are they familiar with desalination? But from our culture, for our psychology, we not like it. As I working for more than 30 years in desalination, it's good water, it's nice, it's no problem. But we have a mental or social or physical or psychological problem because the people feeling unsafe. Because plus some points, like some people say that desalinated water cause some disease and something like that, which is not right. Okay, the less confidence in desalinated water. The operational maintenance, as we mentioned before, sometimes the water quality from desalination affected if the operational maintenance is not good. Especially sometimes because the water hardness is not adjusted, we find the color in the water, so no one of us like to drink a water with color. The other thing in Egypt, especially in Egypt, most of the people in Egypt like to drink a tea. A tea in Egypt is one of, tea is tea. You have to drink tea every day with certain color, with certain taste, everything. The tea itself, when we prepare a tea, it's a chemical process. We put a water and make heating for this water and put some plant with some chemicals in the water, and then we produce the color and the taste. This color and taste depend on the salts in the water. From 50 years ago, from 30 years ago, the average of our age, we drink the tea from the Nile River with this taste and with this color. And if we go to drink the tea prepared from desalinated water, it's totally different. Because of the salts in the desalinated water, not like the salt. And the people in Egypt maybe drink tea 5 times a day, more. So it's a challenge. It's a bigger challenge. And we face it in the sites. And we have to overcome this challenge, because on the other hand, we have to go to desalination. Slide. This is what discussed. The employee working in desalination in Egypt, we have a challenge. We have 2 challenges. One of them is clear here in the presentation, and the other one I will present it. The first one, that the people working in desalination, in the private sector, in the public sector, when they hearing that the government coming and decide to go to BBB model, they thinking the first alarm go to in their mind, they will lose their job. And we discuss it physically with some people. They will lose their job. Is this a fact? If we go to BBB model for desalination, the people in desalination for operational maintenance and supplier and so on will lose their job, or it will be a benefit. We will discuss this in the panel discussion. The second point in the fear of employee, the age Egypt facing this second issue for employees, that we have, if we're looking for the Arab countries and the Middle East, and we see how many projects done in Algeria, in Saudi Arabia, Morocco, and Tunisia, and a lot of people, and all of these projects need more engineers, more technicians, more designers, more supplying, and the Egyptian people have this advantage that they have the Arabic language, the English, they can deal with in these countries. So the market for employees, all of the people who have high skills in Egypt go outside Egypt to find a better opportunity. So we'll face this issue also in Egypt, for example. You have how we can deal with this. Okay. Of course, we have to talk about the taxes and the laws and how the tendering and how we can change mentally in the government and the private sector and in the design, how I will design a project for desalination if it's a BBB project, not EPC project. It will affect the design or not. I believe it will affect, of course, because when it's dependent on the target. For EPC, the target, as I mentioned, we have to implement the project regardless of the price, with minimum price. For BBB, we have to implement the project with optimum water cubic meter cost for a long time. So I think the design the principle for design will be changed. Okay, I will now we propose that we have to overcome this challenge or to improve the environment. We have to have education, training, engineering studies, design optimization, economics studies, research and development, and localization, because the desalination process have a big amount or big margin from the hard currency coming from outside of Egypt, and we need this hard currency. And if we're talking about project for 20, 25 years, we have to localize some industries at least to overcome the needed for the chemicals, for the spare parts along these years. I will go through this presentation to have more time for the questions and discussion. Okay, training and examples of training in Egypt, Saudi Arabia. This examples from research and development studies we prepared previously until the last year. This example how we have to go in deeply in detail in desalination to optimize, not to get from outside only by here. And the economic study that we discuss in this example, a lot of examples. This one example just show if we change the capacity, how the effect if we change the capacity of the plant in the cost. It's one we have a lot of items to study. That was the example. And research and development, of course, to improve the existing research and development, to improve the performance of the existing project, not only for the future projects. Okay. Private-public partnership. This example of the models that normally used in projects normally, and desalination, of course. The last one, design, build, finance, operate, maintenance. The responsibility for identifying the instruction needs and purpose of solutions, the public sector, and the responsibility for project design, financing, construction, operational to be to the private sector, and the ownership to the public sector. This is one of the examples, 4 or 5 examples. Okay, and this table shows how the financial risk transfer from public to private sector. And what is the effect? This is the effect if we go. One of the effects is that if we go to the public-private partnership. And here we propose in 2019 a model. I don't know if it's working. Maybe the financial people say it's working or not. I don't know. That what about if we add for the finance? We add the people, make it like public company, and I can buy a share in this company, this water company, to be like an investor from the people, not only the private sector, to be the private sector, the public. I don't know if it's working or not. It's just a proposal or idea. Okay, not sole properties or companies, not only one company. Okay. And then this is the conclusion for the presentation. And now I think we'll start to the panel. Sorry if it was too long, but I tried to. So we started with Dr. Ater. We have a lot, maybe I don't mention the presentation about the fear of the people that the cost is expensive, the water cost is expensive for desalination, and the people income in Egypt is not too high. And people worry or fear about that they will pay a lot of money and they don't have this amount. How we can deal with it?
In the PPP models that we are implementing here in Egypt and basically in over 80 or 90% of the world, that the desalination projects are an off-take agreement with the government. So the government is the sole client or the off-taking of the entire product of this plant. So the private sector in this case has only one single client, and in other words, one single payer, which is the government. So the government in this model is buffering between the private sector and the cost, on the actual cost of the cubic meter, and the users, which is the public. So the government here is saying, offering. The government have its own policies to subsidize some people and to subsidize some sectors and to overprice in other sectors. So the subsidy mechanism is completely by the government. So in case, just hypothetically, in case that the prices does not change over the next 10 years, okay, and we introduce new desalination projects, the people will not be affected. But the issue is that it came together, the time or the era of desalination, plus the high inflation that the world is suffering from now. So prices are increasing. Even if there is no desalination, prices are increasing because very high inflation. And the subsidies, the government now have a different subsidy system than before, so subsidies should be retreating a little bit. So the prices are increasing in all utilities, not only in water, in gas, in petroleum, in water, wastewater, in the power sector. So regardless. So here the issue of the fear of the high cost of desalination that will be directly reflected to the private sector, this is not the case because the government is a buffering agent and the government is absorbing the difference between this and that in some sense. Plus that the desalination is not that sole source of water, of drinking water. There is a big dependence on the River Nile still, and the desalination will be concentrated on the shores. Thank you. I want to add one thing here regarding this, sorry for that, is the fear was not only from the desalination. The fear is that plus the desalination cost is the intervention of the private sector in the desalination. So as we're talking about the public-private partnership, and the operator here will be the private sector. So in some, on the back head of the people that say that the government is selling us out to the private sector, and the private sector will be doing high profit from increasing the cost of water. Again, this is not the fact because the PPP, as we will see it one day, is depending basically on the efficiency, financial and performance efficiency of the project. This means that the overall cost of the private sector implementing this project should be less than the cost of the government implementing this project. This is called the value for money. This is the first test that we do in our feasibility studies. Is the cost of the government less than the cost of the private sector, overall cost? This is not a PP project. So the PP project fails if the cost of the government is less than the cost of the private sector. And how is the private sector? Normally the private sector is less than the government. But some cases the government is less because the risks of this specific project are very much higher. So the cost of risks that the private sector add to his cost is higher accordingly. This is not a PP project and it goes directly to the government. So the cost, regardless who is doing it, the government or the private sector, this is a cost that the government absorbs. But if the private sector under the PP umbrella is doing or operating this project, financing or operating this project, definitely the overall cost will be less than the government. Thank you.
Thank you. You answered the second question. Mr. Rajesh, your long experience in the countries will be similar to Egypt. How can you advise how we make transfer from EPC or government covering the project for Triple B, make it smooth, and how we can cover this fear for the social fear from the people in Egypt?
Thank you for inviting me to this. Thank you for inviting me to the session. Really interesting topic, and then help us to think much more clearly on this topic. The first question is that who pays for desalinated water? And there are only two sources. Either the user pays or the government pays, which is the off-taker. Now, even in a scenario where we say we cushion the user completely from any tariff increases and the entire fiscal impact is borne by the government, well, ultimately it means that the government's fiscal capacity gets restricted, which means it cannot borrow more, which means that leads to inflation that then directly goes and affects the people. So it's a myth sometimes when we think that, well, if we do a certain kind of contract, the people may not pay, but that depends a lot on the macroeconomic environment as well. And so I absolutely agree with Dr. Anura that in this particular time when you have high inflation, it's really important to understand that the cost of desalinated water is expensive. And once we recognize that it's expensive, the smartest thing for us to do, if, let's say, a particular item in our household budget is very expensive, what do? We try to look for alternatives. We try to look for how much can I get the same value of protein from a lower cost food item. So in the case of water, luckily, we have lower cost sources of water. One of which is recycled and treated wastewater, which even if you treat it to the level of tertiary treatment, will cost lower than desalinated water at this point of time. So the first option would be to see whether are we maximizing the use of the treated wastewater in all of our cities so that we may not need as much desalinated water as we are expecting to be. The second is that how much water is needed. Now, for basic human, let's say, consumption, you could start with 50 to 60 liters of water. But obviously, if you have an underground drainage system and a sewage system, you need at least 140 to 150 liters per person per day. Most cities that provide continuous water and provide well are in the range of 120, 130, 140, 150. 150 is considered fairly reasonable. So the second point is, can we look at optimizing consumption from current levels of 200, 225, 250 to bring it down to more globally accepted standards, or not just accepted standards, prevailing consumption levels in many other cities around the world of in the range of between 100 to 120 to 150 liters per capita. Both these two measures will automatically bring down the total volume and therefore improve the affordability of the government to subsidize desalinated water in the places that you need it the most. Certainly you will need desalinated water in some parts of Egypt, definitely, with the impact of climate change, with all that's happening around us. The question is, how much desalinated water? Where do you need? And most importantly, when do you need? The more we can push some of these decisions into constructing less for the future, we also benefit from the third most important element, which is technology changes. Today, there are a lot of technologies, like 10 years ago, thermal desalination was the default. And now we see that the cost of RO is much, much lower than thermal desalination. It's also much less energy intensive. You have a lot of treatment technologies that are currently in the testing phases, which could be using the natural pressure of the seawater itself to bring down the energy cost to a fraction of what it is today. So the question is, should we invest in huge assets right away in a place where the demand is uncertain and then be stranded with those assets? Or should we be a little bit more prudent to invest only what is the minimum that is needed and then benefit from improvements in technology, both on the desalinated process itself, on energy efficiency, and also on brine management? You have a lot of technologies that are now available for brine management, which can draw useful minerals from the brine and make brine more competitively viable. And the last point that I want to make is green hydrogen is now definitely the technology of the future when it comes to energy. And with green hydrogen, the possibilities increase because you can now store energy, and therefore it's possible to have a completely solar-based, maybe in the next 5 years the technology will be there where you can have a completely 100% solar-based desalination plant with the backup energy coming from green hydrogen that is stored in fuel cells, which can then generate energy for the time when you don't have the grid connection or you don't have. So you're suddenly then looking at a completely different way of producing desalinated water compared to what you have today. The last point that you mentioned about the fueling, the fouling of the materials. Again, a lot of technology research is going on how to reduce and add biological material to reduce the fouling quite naturally. I was in one of the largest plants in UAE last 2 months ago, and they said that by making some improvements, they have now brought down the membrane replacement to less than 8 to 10%, which means they need to replace it once in 10 to 12 years, as opposed to 5 or 6 years, which we normally consider. So I think there is the fact that Egypt is building out its desalination program only now is actually an opportunity. I don't see that as the problem because it can be made more climate responsive. It can be made to benefit from future technology. It's just that I think we need to plan more diligently in terms of where desalination is needed, how much desalination is needed, and by when is it needed, taking into account all the other opportunities that exist in terms of recycling wastewater and becoming more efficient in how we consume. And finally, the last point that I want to make is there are still cities that lose 30-40% of their water. Clearly, desalination is a very expensive way of producing water and then recharging the groundwater by through leaking pipes. So I'd like to end that. Thank you.
Thank you. I have a lot of questions. The time is limited. Mr. Vanish, because as a representative of the company working in the field and will classify the second one as a award now, how we can, did you find that if we go to localization of some equipment or some items in the installation project, it will be affect, and what's the chance in Egypt to do something like that? Especially you have experience in all the Middle Eastern stuff.
Okay, thank you so much for the opportunity. As Mr. Rajesh also mentioned, I believe before I get to your question, I would like to highlight the point that the geopolitical positioning of Egypt in the global map of not just the political map but also the desalination map is very significant because of the fact that you look at the United Nations Climate Change Conference, the COP27, which took place in Sharm el-Sheikh. I think that was the first time when water was included in the final declaration, and it was popularly called the Water COP. So that shows the kind of importance and relevance that Egypt has in terms of water resilience and water sustainability. Most of the points I believe were covered in your presentation, followed by the points made by the esteemed panelists. But coming down to the point of localization, yes, when we look at it from the perspective of either desalination or from the perspective of wastewater treatment, followed by reuse of the treated wastewater, localization will certainly help because one, we are not just looking at the cost impact of localizing the procurement and the manufacturing of the key equipments that are required. The second most important thing is water resilience is not something that is not time-bound. It has to be done in a particular time frame. Most of the global vision statements that are there with regard to the water sustainability, they have a defined time frame of, say, the next 5 years or the next 7 years. All the planning is done with respect to the population projections over a fixed frame of time, and what we are increasingly seeing is that the project execution timelines are also shrinking. And the sooner that you're able to execute these projects in an efficient manner, the sooner the benefits will be for the end users, for the people. So from that perspective as well, from the cost impact perspective, and also from the lead time that we would say for these items, localization will certainly help, because we have seen in the recent past about a few geopolitical crises across the globe, which have hampered supply chain globally, we have seen supply chain disruptions happening, which have escalated the cost, which have escalated the project timelines as well. So from that perspective, we strongly believe that localization, the focus on that, and Egypt has that kind of an environment, both in terms of the way it is positioned on the global map, along the Suez Canal, or even in terms of on account of the manpower that it has to really enable this kind of an environment.
Thank you. Of course, I have a lot of questions, interesting, but the time is out of time, so I will open the question for the audience, maybe for 3 questions.
I'm just wondering, based on your experience, especially in the GCC countries, where they went for coupling power generation and water production, and also district cooling. So now for Egypt, we are seeing building of mega cities like Ras Al Hikma, like Al Alamein. What's your opinion about retrofitting existing power plants with maybe thermal desalination to reduce the cost? I was speaking about cost reduction, about technology of today. So just want to know your opinion on this. Thank you.
So from I have studied the history of the development on the desalination in GCC, and you're absolutely right. The initial development there were largely combined water and power generating plants, and while the specific, I think, energy consumption was high, the fact that those thermal power plants had a lot of waste heat was helpful to be used for the purpose of desalination. But however, I think we have the macro environment has changed, and I would say even the large political environment has changed, that now with climate change being front and center, and even in many of the GCC countries, both UAE and Saudi Arabia, they are in fact retiring their existing thermal desalination plants well before they reach their useful end of life. And the more recent plants are up to 40% hybrid or powered by renewable energy. So I think it's going to be hard to advocate for going back in the evolution and saying that, should Egypt start with thermal desalination? Maybe in some cases where you have existing gas-fired or oil-fired power plants, and if next to that, if there is a requirement on a very case-by-case basis, the waste heat could be used for powering some desalination plant. But I'm not sure whether that can be the broader strategy for on a countrywide approach.
I think also because of the Gulf areas, before they have the Ministry of Water and Electricity under the same, under one umbrella, but in Egypt. So, okay. Any other questions?
I have one question regarding the benchmarking of the cost for the BBB in the GCC countries, and on what criteria we will select the BBB projects here in Egypt.
On what basis we will select the project? I want to clarify something here. In what basis we will select the locations of the projects, or this project is a PP or not? So which is
No, I mean the question was if we have competition between different companies for the triple B, is this the cost is the only criteria for selection, or there are other issues which you have to consider?
in the PPPs in general, in Egypt or the GCC and everywhere, the PPP by nature is a performance-based contract. So the performance is a key element. Okay, and given that the PPPs we do not put in our documents or our tender documents and input specs, we leave the specification and the solution to be selected by the private sector, because he will be more able to select the appropriate technology, to provide the best prices, and to maintain and operate the project properly throughout the project. The evaluation is the operation, technical, and financial. It's a combination. We start with the pre-qualification, and there is some pre-qualification criteria. The most important criteria is directed to the operator. And in the presentation of Dr. Saudi, he was emphasizing on the operation and the operator, because this is the long-term action of the project, it's the operation. Okay? The financing is pushed in the first 1 or 2 years. The implementation of the construction takes 1 or 2 years, and 25 years or 30 years of operation. And all this investment could be demolished if the operator is not performing well, and termination takes place. So the first thing is the pre-qualification, where we select the shortlisted consortium, and the operator have special criteria. If it's not fulfilled, they are not qualified. Only qualified bidders, so we're having here some kind of a high level of competitors. So that's to ensure that the quality of the technical bids would be up to the standard. That's the first phase. Then, in the technical and the financial office, there is 2 methods to evaluate the PP projects. One is pass or fail technically. If he passes technically, then he passes and we get the least price. Or the pointing system, and we have an equation and our law and our regulation that have a weighting system between the financial and the technical. It's not as the procurement law, which they take the financial cost and divide it by the number of points or whatever. It's not like this. In the PPP law, we have an equation where we first have to determine the weight of the technical against the weight of the financial. 70-30, 60-40, 65-35, 50-50, depending on the nature of the project. If we're going for a nuclear plant, for instance, we go 90-10. 90 technical and 10 financial. If we're going for a straight solar energy, we go something like 50-50, because the operation here is very minimal. Okay? Wastewater treatment plant, the last time we went to 35-65, technical and financial. So this is another methodology. The third methodology, that is very well spread, that we have a pointing system for the technical. And we say that any technical offer should exceed 80%, 80% of the points. Okay? Once he exceeded the 80%, then he passes, and we go for the rest price. So there's different. In the wastewater treatment plant, the cost is significant. Okay? And we want to make sure that we get the best price and the best technical offer. And given that we're doing the pre-qualification, selecting the top-notch consortia with an perfect operator and designers, okay, we normally go for the pointing system with a minimum threshold of 75 or 80%. Whoever achieves the 80% or 85%, then he's technically qualified, and we can go for the best price, because the best price is another significant. So this is a compromise between the best technical and the least financial. Thank you.
So, as a last question, any other question?
I know this. Everybody here is talking about private sector and the profit coming from desalination, how much it costs. But as a water resources advisor and climate activist, I'm worried about the environmental impacts of the desalination projects in Egypt. As we know that if it's renewable energy is not used, it's heavily dependent on fossil fuels and it's increase the greenhouse gas emissions. So is this taken into consideration when you choose the place for the projects, the desalination projects in Egypt, and if this will be considered? We already seen this in the Gulf countries, the impacts on the marine and the life and the ecosystem. So if the negative impacts of desalination projects will be taken into consideration. Thank you.
Yes, it is taken into consideration when the government decides to have the triple B, to go to triple B. They hiring international consultants first, and makes the studies include everything: technical, financial, environmental, social, all of these impacts be considered. And if we have some red flags or something not able to make the project inside, will be cancelled. Yes.
I actually want to propose the idea that desalination is actually an adaptation initiative. So it's as much, we have to look at it from the adaptation angle as much as reducing the mitigation. Because let's bear in mind that climate change is affecting the availability of fresh water, which is causing population and governments to look at alternative sources of water, and desalination is, there is vast amount of seawater available. Now, admittedly, the local mitigation effects have to be managed. So clearly the way that the brine diffuses back into the environment needs to be addressed. But as I mentioned, there are technologies that are coming in terms of brine mining, which can completely take away the need for putting the brine back into the water. So that's one. Second, I'm not too sure whether scientifically the impact of desalination has been completely isolated on various places. We talk about the Gulf and GCC, but let's bear in mind that these areas also have high amounts of radiation, which means that the water that is lost from evaporation is probably many-fold compared to the water that is being drawn for desalination. So I'm not sure that there are very robust scientific studies that are available that can actually isolate the impact of these kinds of, I think more work is needed, especially on things like cumulative impact assessment. As more countries, let's say in the Red Sea, start to set up desalination plants, maybe it's possible that 5 plants may not have that much of an impact, but a 6th one may be like a trigger, which could completely reverse or which could increase the negative impact. So that's why perhaps more regional work is needed in the Red Sea area at least, and probably even in the Mediterranean. I would say Mediterranean has much better circulation. So to that extent, the effect is mitigated. But along the Red Sea, which is much narrower strip, much more collaborative research is needed on understanding the impact, because the ecology here is very fragile. There is impact on tourism. So that's one of the things that probably the government should be putting its effort, because that's really a public good. Environmental impact is really a public good, and I think it will be hard to expect the private sector to put in as much effort on that. It doesn't happen anywhere in the world, and I don't think Egypt would be any exception. So that's something that has to be completely done by the government.
I just want to elaborate on what you were just mentioning and implementing this in the case of Egypt. Actually, the planning committee, which is headed by Dr. Said Ismail, selecting the locations and testing each location. We got advisors and consultants checking this everywhere. And in some areas, the plan is revisited and the capacities are revisited, given that there is a high environmental impact in this case, and there is a red flag here. And actually, I want to tell you that some of the sites are completely cancelled, and they're revisiting the places again. So this is taken into consideration at a very high level, and this is one of the issues that actually delayed a little bit the implementation of the project. Thank you.
Thank you, Dr. Atrus. Thank you, Mr. Rajesh. Thank you, Mr. Kanish. Thank you for all. We have to finalize this interesting session, but we have discussion, but we have to. We already have an hour more than the plan. Thank you very much.